Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in calculus, particularly on the applications of the slope of the tangent to the curve. And also included here is the interpretation of the slope of the tangent to the curve, as well as the applications by plotting curves and determining equations of tangents to curves. Allow me to present the solution to these two problems with less animation so that I can explain and solve these two problems in a short while. So here is the first problem. Let B of t be the total value of US banknotes in circulation at time t. The table gives values of this function from 1980 to 1998 at year end in billions of dollars. Interpret and estimate the value of B prime 1990. So the geometric interpretation is it is the slope of the tangent to the curve at 1990, but practically speaking, it is the rate at which the total value of US banknotes in circulation is changing in billion of dollars per year just after 1990. So we have here the given table, and we're going to estimate the value of B, the total value of US banknotes in 5 years after 1990, because from the slope of the tangent to the curve at 1990, there's no available data, but in 1995, after 5 years, there is, but the ordinate to the tangent to the curve is not specified, so we have to estimate it by drawing the tangent to the curve. So these are the plotted points: 1980, $124.8 billion. So this is in billion dollars, and this is the year 1985. We have 182, 1990, 268.2, 1995, 401.5, and 1998, 492.2. So we draw tangent to 1990 here. So that's the curve. Then let's draw that tangent. So that after 5 years from here, we have to estimate this intersection of the tangent and estimate the US banknotes in billion dollars, and after 5 years. So that's approximately 378. This is 5 years. This is 268.2, which is given, and that's 5 years. So the interpretation of B prime, which is this slope here, this is B prime 1990 is the rate at which the total value of US banknotes in circulation is changing in billions of dollars per year just after 1990. And geometrically speaking, it is the slope of this tangent to the curve. And the slope of the tangent to the curve specifically is 378. My estimate, you may also estimate that minus 268.2, then divided by 5 years. So therefore, the value of B prime 1990, the rate of change, the rate at which the total value of US banknotes in circulation is changing, just after 1990 in $1 billion per year is 21.96. So that's it for that problem. Then we proceed to the second problem. Graph the curve y equals x plus 1 over x minus 1 and the tangent lines to this curve at the points 2, 3 and negative 1, 0. What are the equations of the tangents? Of course, tangents to these 2 points here. These are the points of tangency. So first, let's have the vertical asymptote is the value of x where the denominator is 0. So x is 1, vertical asymptote. The curve approaches but never touches the vertical asymptote. So we have x equals 1. The graduation for y is different. It is by 5s. The horizontal, it's by 1. So for the horizontal asymptote, we evaluate the limit of this function as x approaches infinity. But before that, we divide everything by x. So we have 1 plus 1 over x over 1 minus 1 over x. As x approaches infinity, this is approaching 0. This is also approaching 0. So 1 over 1 is 1. The horizontal asymptote, therefore, is y equals 1. So it's not shown here, but it is y equals 1. The curve also approaches but never touches that line, horizontal line, y equals 1. Same is true with the vertical asymptote, also not shown, but this is x equals 1, the vertical asymptote. Horizontal asymptote, y equals 1. Then we plot the following points within the limited screen. So we had to consider negative 4. We just substitute into this equation here, or since this is calculator aided, you may set your calculator in the table mode, then define this function. Start maybe negative 4, step maybe 1, and that's it. It ends at 10 maybe, or you just calculate y for these assigned values of x. So when x is negative 4, y is 0.6, so which is this. When x is negative 3, y is 0.5, which is this. When x is negative 2, y is 1/3, which is this. When x is negative 1, y is indeed 0, which is this. When x is 0, then y is negative 1. You just insert 0, negative 1. When x is 0.9, because x is 1 is a vertical asymptote, y is negative infinity. So just to have an idea that the curve is going down and it will not touch that vertical asymptote x equals 1. When x is 1.1, y is 21. 21 is also not seen in the figure, but just to give us the idea that it approaches that vertical asymptote. Then when x is 2, y is 3. When x is 3, y is 2. When x is 4, y is 5/3 or 1.667. When x is 6, y is 1.4. Not seen here, but if you prepare another graph, then it should pass through x is 6, 1.4. When x is 10, 1.222. Then when x approaches infinity, y approaches 1, but it is higher than 1. So that's why the curve looks like this. So connecting these points with a smooth curve will reveal this graph. So this is the graph of y equals x plus 1 over x minus 1. Then for the tangent at the point -1, 0, we first derive an expression for the slope, which is the derivative of y with respect to x. So y prime, so we have denominator x minus 1 times derivative of the numerator, which is 1, minus the numerator x plus 1 times the derivative of the denominator with respect to x, which is 1, all over denominator square. So y prime is equal to, so we cancel x, so -1 minus 1 is -2 over x minus 1 squared. The slope of the tangent when x is -1, so substitute -1 here, -2 over -1 minus 1 squared, that's -2 over 4 or -1/2. Then the equation of the tangent is by point slope form, y minus 0, y1 is 0 here, is equal to slope -1/2 times quantity x minus x1, so x minus -1. So simplifying, the first tangent is y equals -x over 2, then minus 1/2. To sketch the graph of the tangent, this is the first point, -1, 0. The second point is 0, -1. So which is this? Then connect with a straight line, that's the first tangent, y equals -x over 2 minus 1/2. For the second tangent, we compute the slope of the second tangent at the point 2, 3. So -2 over quantity 2 minus 1 square, that's -2 over 1, which is -2. So the slope is -2, which is this, and substitute into the point slope form, y minus y1, so y minus 3 equals slope -2 times quantity x minus 2. Simplifying, y is equal to -2x, which is this, -2 times -2 is 4, then plus 3 is 7. So y equals -2x plus 7. The slope is -2. The y-intercept is 7. That's why it passes through 7 here, 0, 7. And this is the first point, then extend the line. So this is the tangent, y equals -2x plus 7. So that's it for this video. I hope that you were able to understand the explanations and the solutions.